Welcome everyone to this Forge College Explainer. I'm absolutely thrilled you're here with us today. We are jumping right in to set the stage for your Ethereum capstone project, and today is all about synthesizing security and operational trade-offs. We've spent a ton of time gathering this incredible raw data, right? Well, now it's time to actually engineer that data into something powerful, a final, undeniable blueprint. Let's get started.
Okay, first things first, I got to acknowledge the whiplash you might be feeling right now. Seriously, in our last lesson, we were moving at light speed, totally focused on the fast, tactile execution of Solana CLI workflows. It was all about speed, immediate feedback, punching in terminal commands. But today, we are slamming on the brakes. We're pivoting deep into methodical Ethereum account model synthesis. It's a huge shift from tactical on-the-ground execution to high-level architectural engineering. So, take a deep breath, shake off the terminal dust, and let's switch gears.
Here's our engineering blueprint for this explainer. 1. Data to defensible claims. 2. Extracting evidence. 3. Mapping metrics to reality. 4. Writing the core synthesis. 5. Limitations and reproducibility. And finally, 6. Finalizing the blueprint.
All right, Section 1, Data to Claims, Translating Metrics.
So the big question hanging over us is, what exactly are we trying to build out of all these raw metrics we've collected? The answer, in a word, is synthesis. Synthesis is just the process of translating your raw dataset measurements and comparative frameworks into evidence-backed, defensible conclusions. Notice I said evidence-backed. We are engineering a structured argument here. We are definitely not writing some late-night, caffeine-fueled opinion piece for a Reddit forum. Your peers need to be able to follow your logic step by step, reproduce your findings entirely from scratch, and ultimately agree with your conclusions based purely on the math. Moving right along to Section 2, Extracting Evidence, Filtering Raw Data.
Let's look at the actual mechanics of this build. Look, if the idea of writing a massive capstone feels totally daunting, which is totally fair by the way, I want to give you a very comforting roadmap. We're going to break this giant task down into 3 highly manageable, almost paint-by-numbers drafting passes. First up is extraction, that's just isolating the evidence. Second is mapping, translating those metrics into actual impacts. And third is the write-up, composing the final narrative. Just 3 clear, logical steps.
In that very first pass, extraction, you really shouldn't be drowning in data. You kind of have to be a ruthless editor here. Only filter for the highest weighted metrics that you defined in your comparative framework. Find the top 10 drivers. The specific accounts or smart contracts that are actually pushing those metrics up or down. Once you've got them isolated, save them as CSV files. And, this is absolutely crucial, record the exact scripts you use to extract them. This provenance metadata, it's literally what separates a rigorous professional analysis from a cheap magic trick. Reviewers have to know exactly how you pulled your numbers. No black boxes allowed.
Up next, Section 3, Mapping Reality, Metrics to Trade-offs. This right here, this is the absolute crux of this entire explainer. We are taking abstract numbers and turning them into real-world operational realities. To organize the chaos, you're going to create a canonical mapping table. It forces you to perfectly couple every measurable metric with a direct consequence. Let's look at an example. Take a metric like growth. Well, the real-world phenomenon there is long-term storage costs, right? Which then introduces the security concern of state bloat. Ultimately, this highlights a massive operational trade-off, the cost of archiving versus running a full node. And right next to it in the table, bam, you drop a dataset pointer to prove it. Or think about abstraction. An expanded attack surface means an operational trade-off between network flexibility and user key management UX. You're mapping the so what directly to the data.
Let's hit Section 4, Core Synthesis, Drafting the Report. Now we're entering the third and final pass. This is where we take those beautifully mapped components we just talked about and actually string them together into the text of our report. You do this by sticking to a really strict microstructure. Every single time you make a point, follow these 5 steps: a clear claim, a mechanistic explanation, the dataset evidence, the operational implications, and finally, suggested mitigations. If you strictly follow this discipline, each point takes about, say, 200 words. String 3 to 5 of these together, you've got yourself a beautifully tight, bulletproof core section that is purely analytical.
Honestly, the difference this structure makes is staggering. Let me show you what I mean. Consider a casual opinion like, account abstraction is risky. Okay, that's flimsy, right? It's easily dismissed. But apply our new microstructure and it becomes, dataset index 3 shows complex recovery flows expand attack surfaces, creating a trade-off between flexibility and UX burdens. Wow. That transforms a loose opinion into an undeniable engineering fact. As a reader, I literally can't argue with it because you've handed me the exact index to go verify it myself. Game changer.
Section 5. Limitations. Ensure reproducibility.
So, we've built a really strong argument. But an engineering blueprint is only as good as its tested limits, right? It is time for the reality check phase. Exhaustively documenting your constraints is how you armor your capstone against peer critique. You want to point out your own flaws way before anyone else can. So, list your data gaps. Note your temporal constraints, like is this data just a snapshot in time or is it longitudinal? Propose future experiments to narrow any uncertainty. And again, super important, provide exact checksums so peers can test your work from scratch. Transparency is your absolute greatest defense here.
20%. So let's talk about why this exact number is going to completely make or break your analysis.
This is all about sensitivity analysis, which asks a somewhat terrifying but totally necessary question. What happens if a plus or minus 20% shift in a metric's weight completely shatters our conclusions? You have to compare your top-level conclusion under its original weighting against an adjusted 20% weighting. Stress testing your normalization rules like this reveals if your operational trade-offs actually hold up under analytical pressure, or if they're just a fragile house of cards based on some lucky data. And hey, if your conclusion flips because of a minor weight adjustment, that's okay. Just state it clearly in your limitations.
Finally, Section 6, Finalizing Blueprint, the final polish.
We are in the home stretch, folks, but before you tag your draft and confidently hit submit for peer review, run through these concrete acceptance criteria. Check 1. Does every single claim have an inline evidence pointer? Check 2. Are 3 operational trade-offs fully explained? Check 3. Do you have 5 limitations and that 20% sensitivity test included? Check 4. Does your reproducibility appendix work perfectly from scratch in a fresh environment? And check 5. Is your formatting spotless? If you can check all 5 of those boxes, your blueprint is officially ready to go.
I want to leave you with this final, provocative thought. You aren't just writing another paper here. You are analyzing the literal foundation of Web 3. How will the operational trade-offs you mapped out today shape the decentralized architecture of tomorrow? The synthesis you just engineered is the analytic spine of that future. Pretty cool to think about, right? Thank you so much for joining me for this Forge College Explainer. I strongly encourage you to head over to our website at forge.college to learn more about this subject and dive deeper into some other fascinating Web3 topics. Keep building, keep analyzing, and I'll see you in the next Explainer.